Well, here's a few news articles that you might like. This one I thought was very nice. Caitlin's going to be teaching a workshop soon, which is on my website, about hacking space. And this is the kind of stuff you do. In some of the, Quiz 9 should be available now. We found that it had not been published on the non-CCSF student website, and we just published it about half an hour ago. So take a look and let me know if there's still a problem. Good. Anyway, so this I thought was very interesting. I might like to try this. You get a software-defined radio, which is a little USB device that takes radio signals and feeds them into your computer, and then you get a gadget, a wireless gadget. And you can do fun attacks here. Like he bought some kind of gadget that's a doorbell that runs at 433 megahertz. And now he can pick up the signals from it. This is what the tool you use looks like, and I've used this a bit to analyze signals from satellites following Caitlin's tutorials. It's a thing actually NASA uses a lot. You plug in data, you plug in these modules, and you can take radio signals and analyze them various ways. And so then you find the signal. And this is just the amount of signal at various frequencies, and you see it is in fact picking up in this around 433 megahertz. It's sending some kind of data, and then you can record that data and replay it and try to do a replay attack, which is the simplest and would probably work for most of these things, although hopefully not for unlocking car doors these days. And he talks about how to process it and perform that attack. So this looks like a lot of fun. So I may try to get this working. Which course you're talking about, where you used it? Oh, they've got a space hacking workshop. And there, right here, this one, Pacific Hackers on May 15, we're going to do it. And there's a series of projects here that I'm just following Caitlin, and we pick up signals from satellites and built special antennas and decoded them. And she's probably going to add some more to this. And I think analyzing IoT devices and radio waves would be another good thing to add to this. So we're still developing this, but we're hoping to get a good workshop going there, and then we'll probably do it at all the DEF CON and all those conferences and such. But anyway, everyone can come to this one. Pacific Hackers is open to everybody, and that'll be in May. Anyway, so these guys tested the websites because, as I think everybody has known, is it legal to access high band frequency? Well, as far as I know, it is legal to listen on any wavelength. Now, if you want to transmit, there are rules. There are certain regions you can't transmit on, and for certain regions you have to have a ham radio license, and so on. But if you're just listening, I think that's legal on every band. Although if you were to listen and pick up telephone traffic, you might be breaking a wiretap law. But pretty much, I don't think there's any. I don't think it's any kind of crime to listen to signals that are coming in. Anyway, although I'm not a lawyer, and it is more complicated than simple rules being 100% right. The other thing, of course, is if you're just listening, there is no way for anybody to know you're doing that. So if you don't go advertising it, then you'll be safe. Anyway, so these guys check the websites. I think as anybody that's been looking for the vaccine, like I was, can tell you the websites are terrible. They crash all the time. They're contradictory. Americans are pretty much scrambling to get the vaccine and having great trouble finding it, although apparently quite soon that's going to get better because they vaccinated all the early adopters and they're getting down to where people don't really want to get vaccinated, so they're going to be like trying to make you take it, and there'll be tons of extra vaccine everywhere. So probably within about the next month, it'll just be everywhere where you can't do anything without somebody offering the vaccine, so it'll be easy enough for everybody to get. But anyway, they checked these websites and they found that people are struggling greatly, and they ran various tools. There's a tool to see how many cookies and trackers there are on the website, and so on. Another one checking performance and accessibility. And of course, they have all kinds of trackers, and they have all kinds of privacy violations, and their performance is terrible, as anybody can tell you. So, you know, it's interesting to see a nice analysis of them. Getting real data to back up what I think the rest of us anybody of us could tell you, that they're very badly designed. Many of them take far too long to load. They crash all the time. And everybody I know that got the vaccine had to go through several layers of broken websites to get there. It is one of the many disasters caused by us not having a national health service. Since we don't have any socialized medicine, there is no infrastructure in place to deliver medicine to the people. There's just a whole bunch of random pharmacies and companies and stuff all doing random foolish things, and the government is not helping much. They have central servers, but most people discovered they're so bad you shouldn't even use them. This thing I just learned about, the PRO Act, this thing is a bill to try to improve labor unions. Labor unions have been gutted in the United States for the last couple of decades because of the Right to Work Act the Republicans passed through that meant that nobody, if you work at a shop and there is a union and the union negotiates a contract, you are not required to pay union dues unless you join the union, even though you benefit from what the union does. And what that does is it starves the unions of money. And there are other things that go on to make it very difficult to unionize and make unions extremely ineffective now. And so this act would reverse that right to work thing from the Republicans, which is very much like their current bills to suppress voter access. And therefore, of course, it would do a lot of good. And of course, it will never pass the Senate unless they get rid of the filibuster, which is true of essentially everything. And I think this is now the defining issue of our age. The one bill they got through was the COVID relief bill, and they're going to get one more through, which is going to be an infrastructure bill, and they can do those with reconciliation. And after that, absolutely nothing more will get done unless they end the filibuster, which is the big battle of this presidency. Anyway, the British coronavirus variant, which is spreading in Britain and now spreading in America too, has apparently been proven to be more dangerous to children. And this, I think, is a real game changer. If it actually hurts children more, then I think everyone will greatly change their attitude about it. So that will make a big difference in things like opening schools and vaccination. Right now, we don't even have a plan to vaccinate the children. They're still doing early testing. The current plan to vaccinate children, like below 12, is not until next year, I think. So if you can't vaccinate the children, then you really have to vaccinate the adults so it doesn't spread to them. So this may make a big difference. Anyway, so this one ought to strike close to a lot of students. These people went to the University of Phoenix. The University of Phoenix was a huge pioneer in online education. They've been advertising it everywhere for about 10 years, and apparently they've gone too far and promised jobs to students, which is the same thing most of the for-profit schools did. They promised like a 95% job placement rate, like DeVry and Heald and all those, and it was, of course, a lie. Nobody can do that. And they've got sued for not doing it, and now the University of Phoenix has gotten sued for the same thing. They claimed they had partnerships with AT&T and Microsoft and Twitter, and you would get jobs, but in fact, none of that was true. I think they just were teaching about those products, but they didn't have a deal that would get you a job. And so they've now been sending out $50 million in refunds. People are getting their money back who signed up based on those deceptive advertising. So it sounds like a pretty good attempt to repair the damage done. Vaccination on any age group still not started here in Germany. Wow. They aren't doing vaccination at all yet. I didn't know that. Wow. I thought Germany was pretty forward on these things. Wow. That seems like a really bad idea. I'm surprised the Germans don't have the vaccine. I thought they would have, the ability to manufacture it, the ability to buy it, and I'm very surprised to hear that. Yeah, how can they be so slow? I mean, I thought America was doing a terrible job. I just sort of assumed the Germans would do better than us. But anyway, all right. And we only got a couple more minutes. I think I'll skip this one. This is another one that I was amazed at. In China, primarily, although some other countries, these people have AIs that just write fake scientific papers so they can claim to have scientific prestige at their university or get jobs, and they just copy images from other papers, and they say the way people find these is humans read the paper, and you just notice that it's got the same figure in like 5 different papers that are supposed to be on different topics. They're made I'm not sure they make them by AI or what, but they're just basically, substituting in the same figure over and over. They're hoping nobody will actually read the paper, which is apparently quite commonly true. And they find thousands of these papers, more than 1,000 similar studies. So a whole lot of these papers are fake. I know I met a guy when I was in grad school in the 80s that had a PhD from Russia, and he was back at the University of Illinois earning another PhD. And he told me, if you have a PhD in physics in Russia, if you come to America, they don't honor it. And another person, many years later, another Russian told me that that's because a lot of people in Russia, they get their PhD by just translating an American PhD into Russian and then claiming they wrote it. So apparently there's a lot of scientific fraud there. There's a lot of scientific fraud here too. In my field, which was medical work, there was a guy named David Baltimore that had thousands of research papers about cancer, and they were all fake. He had to spend years fixing them. So it is a huge problem that scientists fake their work, fake their papers, and so on. And of course, it's easy to do for the same reason a lot of tech scams work, because a lot of people can't understand what scientists say anyway, so they can't tell if they're telling the truth or not, which is essentially the entire world of cryptocurrency and blockchain right now. They dazzle people with these complicated terms so that they don't ask questions, and then they can just tell them any lie and pick their pocket. Anyway, so we're here. This is 129S, and I've got a very fun demo later, but we'll start with the database lecture, and then I'm going to show you a demo of getting past paywalls. I tried to read an article, and there was a paywall in the way, and I started counting all the ways I knew to get past paywalls, and I said, well, this would make a good demonstration for class. So let's start with the slides, which are here. And this should be in the area of a review, because am I sure? Kazlinski, are you sure? Well, that's what I don't know. Okay, good. I must be talking about the Germany. Anyway, so, all right. So if you're trying to do SQL injection, you might find that the app has made some attempt to prevent SQL injection by doing things like blocking quotation marks. And that would make it so that the standard SQL injections don't work. But of course, if you're injecting into a numerical field, you don't need quotes around the argument, and you don't need to inject a quote to inject code. You can also sneak, if you have any kind of filter, and this is going to be through this whole course, all these attacks, they say, oh, just sanitize the inputs, but that turns out to be a very weak defense, because there are many ways to sneak a character through. For example, if you need to put in a forbidden character, you can just put in the character code, have a formula like function that will turn the number into the quote, and this is not a quote, but it could be, and then you snuck a quote through. You did not literally type a quote, but you've given it some function to evaluate, which will result in a quote. That's one way to get through. And if they block the comment signal, here's a common one. You try to put in this common injection with the dash dash for a comma, but they block the dash dash, so the comment doesn't take effect. And now you, instead of getting a SQL injection that will log you in as the first user, you just get a syntax error. So if that happens, you can avoid using a comment. If you do this, apostrophe or A equals A, with a missing apostrophe here, then when the developer's apostrophes go on the start and end of this, this will again create a condition that is always true, as you see it here, where name equals blank or A equals A, and you do not need a comment at the end to eat up an extra apostrophe. That's one way to do it. Use that one all the time. It works more often than the other one in my experience. If they block select, for example, there's no reason to put select in your name or anything or your password, then you can try variations. Change the case, put a null byte in front, put one select inside another select. So if they have a simple one-pass grep filter, it will just find this one and cut it out and not notice that what's left contains another select. You can space it out with the ASCII characters. You can use double ASCII encoding. The %25 is a percent. So if this thing passes through two stages of normalization, which is fairly common, the first one will normalize this down to a percent, the next one will normalize that %53 down to an S. And again, you have managed to insert the forbidden characters without exactly putting them where the filter will see them. If you're going to have something like a web application firewall, it has to decode all these different versions of a character all the way down the same way the application will to find the bad characters to block them. And that turns out to be nearly impossible. So that's the trick. That's why blacklisting, listing all the bad characters and removing them, is considered a weak defense, because there is almost always some way to encode those characters that will sneak past it. What's a much better defense is whitelisting. After all processing, the last one is double encoded. What's a much better defense is, after all processing, check the output of that and see that it doesn't contain any forbidden things now. Not at input, but at output when it's passed to the next stage. Anyway, you can have comments. For example, if you can't put in spaces, then you can't put in select password from users, but you could put in comments instead of spaces and it'll take it. And MySQL will even allow you to put it in the middle of words like select and from. So again, this will no longer contain the forbidden characters, forbidden word select, but it will be interpreted as select when it's sent to the database. And then there's second-order SQL injection, which is another fun trick. You can inject data which does not cause SQL injection now, but it will cause SQL injection later when that data is used. So if you register an account, you might be able to register an account with a name containing an apostrophe. And then, if they've done it correctly, the official way you're supposed to do it in SQL is, if you have to have an apostrophe in a name, you put 2 apostrophes. And it will then interpret that as a single apostrophe. That is its attempt to handle this problem. So if you do that, then when you try to input so if you do a password change on that account, after you've inserted an account with a single apostrophe, it will now try to select the password here, and that'll be a syntax error because of the extra apostrophe. So you can make an exploit with this name, with an apostrophe and this stuff. And the point of this is, it's going to try to compare the number 1 to a password, which is the administrator's password. And what happens is, Microsoft SQL will consider this an error. You can't compare a number to an alphabetic thing. And the error message will include this value. That's the administrator password. So that's one way to exploit it. And that's second order or stored SQL injection. All right. Now, these attacks we talked about are not blind SQL injection. They're the kind of SQL injection where you can see something on the web page that reveals some data from the database or error messages. That's the easy kind. The nasty kind is when you can't see what you're doing. Now, there's also tricks like just denial of service, shutting down the database, deleting data. You can do that too, but of course that's not usually as useful as exposing data or getting a shell on the server. If you are trying to get data out, but you only have access to a numerical field and you want to get out strings, then you can use things like ASCII and substring to turn letters back into numbers. So this would return the first letter of that, and ASCII would return 65, so this would return 65. So now you can put a select here that selects for the password or whatever you want, and turn the characters one by one into numbers to get them out in a numerical field. And you can use an out-of-band channel. There are ways to make connections. For example, you can, in early versions of Microsoft SQL, you can actually tell it to send the data to a server on the internet with a URL and a port number, a name and password. So it would connect to this server and send the results over there, which is really just asking for it. So that's nice, but of course they took that out. In Oracle, you can make an HTTP request inside there, and then you just have to make a netcat listener, and it will send whatever you told it to send up to the server. That's a common kind of data exfiltration. And if this one's going to send it, I think, as an HTTP request, that might possibly get blocked. For example, if your IP address there is in a blacklist, what might be better is to use a DNS request. This will just try to resolve this name dot domain, and this name looks like a server name, but it's actually a hash value from a password. So this is commonly done, and I've got a project in one of my classes where you get to see where you track down traffic like this. This is what you typically have when you're infected by bot malware, your bots will send beacons home, and they will be HTTP or DNS requests with long names that include encoded information, like identifying the bot, sneaking out private data off the machine, and so on. This is a way to exfiltrate data because it'll try to find this server, and it won't find that server, and it will ultimately ask your authoritative server for your domain. So this request will find its way back to your domain server, and you just have to watch the requests coming in, and the data will be in there. So here's MySQL. We've done this in this class. Select data into an out file. You can put it in a local file, or if you can get connected to the network and start a SMB share, you can send it right to your machine, right into your share. But of course, you have to have a VPN connection into the network or some other kind of network connection to do that. And sometimes you can get all the way down to shell commands. There are ways to do that sometimes, like Microsoft's XP command shell routine and such. And then you can use all the built-in commands that send network traffic. So let's take a look at the cahoots. And I got them here. Supposedly, this will be 129S, Chapter 9B. Yep, this one here. Yeah, domain name generators. Yeah, same kind of thing. Yeah. Good. It's better if we have more than 3. Otherwise, the competition becomes kind of less interesting. You may have only 4, however. All right. All right, so if comment signals are blocked, what would you use? All right, there you go. This one here avoids the need of a comment signal at the end. All right, which one will expose a secret in an error message? Okay, that's the one. We'll try a numeric number looked for in a string. That'll create an error message. All right, which one bypasses keyword filters? Okay, that's this one. All right, so mom gave her child this name. What kind of SQL injection is that? That is second order. It does not have any effect when you first create it, but when it's used later, it will have an effect. All right. All right. So let's carry on. All right, so now I got blind SQL injection like I was talking about. Suppose your query does not return any data. For the second order one, isn't the input already sanitized? Oh, if it is, yes, second order SQL injection only works if the input is unsanitized and stored in that way. You have to actually get an apostrophe in there. Now, but like I say, in SQL, it will store 2 apostrophes. Let's go back up to this one. Yeah. There. So if you do that, it will actually store it with 2 apostrophes. But then when it retrieves it, it will interpret that as 1 apostrophe. So it will retrieve this name correctly, foo with 1 apostrophe. And then when it tries to do this, it will have an error here. So that's the point, because this is an imperfectly thought out system where they tried to make it possible to have an apostrophe in a name. And the point is, if you use SQL correctly with parameterized queries, that would be fine. You could store an apostrophe in a name and you could use it. But if you're going to store apostrophes in names, you cannot use this kind of select command where it uses apostrophes as delimiters. You have to use parameterized queries, which we're going to talk about in the 3rd section. So that's the problem. Real names do have apostrophes in them, so you really should not be using this kind of syntax where apostrophes have a special meaning. But a lot of people make that mistake. In case of a payload, like in Kahoot question 4, it'll probably be detected pretty quick and not allowed. No, it would be, well, if you had any filtering, yes. But if you don't have any filtering, then it won't. Then it'll just go in. You're allowed to have parentheses and apostrophes and such. The language itself is capable of storing special characters in here. So, I mean, you're right. If you have filtering, it would be blocked. But if you don't remember to filter the input, there's nothing in the database by default that would prevent that. Because you're allowed to have a line of text, including punctuation marks, in a string. Anyway, so if there's nothing on the page that came from the database, then you have to use some indirect technique. Like, for example, here, I'm going to have, say, injection in the username. So I can put this in as the username, and I'll be logged in as admin. So I can make this, I guess second order is done in case of any other ones are filtered. Well, yeah, you're going to have to, well, you do second order. Yes, you probably do second order because the other ones are not available. But the second order could also be filtered. But what you do is you run a scanner and it tries every field and you find out what fields have vulnerabilities. But the ones that don't reply right away, it's kind of hard to tell they are vulnerable. Anyway, so this would log in as admin and this one won't. And you did this in the SQL injection project. You make a compound statement with an and in it, and now you can find out if the second condition is true or false. If it's true, it has one effect. If it's false, it has another effect. So now you can do the blind SQL injection thing where you ask yes or no questions. So this one will log in as admin, and this will not, because the first letter is capital A is 65, but it's not 66. And so you can ask a question about a password or anything you want, one question at a time, and pump out data. So on an Oracle database, this one here will look to see if there's a username equal to DBS NMP. And if there is, then the condition will be true, and it will then try to select 1 over 0, and then it will crash because it can't divide by 0. If the condition is false, it will not. So this is another way to ask a yes or no question. You'll get an error or you won't. And here's one that would check to see if that username exists. You can also use time delays, and we did this in that SQL injection project in the extra credit parts. There may be a delay command or a sleep command that you can use to slow down the response. So you can have a conditional where if something is true, wait for a delay, otherwise don't, and then you can find out which one takes longer, and that'll be the condition that's true. And you can change single bits. You could try a letter one by one, or you can take the bits of a letter. This will take the first letter and then do a bitwise AND with 2 to the 0, so it will get only the lowest bit, and then it'll see if that bit is greater than 0 or not. So you could do 1 bit at a time, and then 7 bits would be enough to trace out an ASCII character. MySQL has a sleep function. Other ones, you might have to run some kind of benchmark function to make a delay. Oracle doesn't have a delay, but what you can do is you can connect to a server that doesn't exist, and then it will spend time connecting and giving up, and that'll amount to the same thing. So here it is. This will perform the delay if this condition is true, so if a user with that name appears. All right, and so beyond SQL injection, you can try to compromise the operating system underneath it. And then you can use the database server to attack other machines and make network connections back using other functions. If you can get database administrator within the database, you can then turn off the security features of the database and introduce dangerous functions that have been disabled. For example, Microsoft has this thing called XP command shell that lets you put command lines in the SQL data, which was really great for SQL injection, but now it's turned off by default. But it's still included in MS SQL, so if you get Database Administrator, you can turn it back on, or you might find databases where people have left this turn on, and then you've got trivial command injection right through SQL. All right, and there's other commands in there like regread and regwrite that'll read and write to the registry, and you can do everything on a Windows machine by affecting the registry. All right, it's locked down by default on modern versions of MS SQL, but you can just enable it. It still exists in the software, you just have to enable it if you get Database Administrator. You can load a file here to load a local file and into out file. So for example, this would change the etshosts file, which is what determines who's allowed to connect to, I think, an X server and so on. So you can change system files to lower the security of the box. And there are tools, of course, like SQL Map that will do these things automatically to find things. So here's the algorithm. First you try sending special inputs like punctuation marks to all the requests to try to find where it'll create an error or an unexpected result. Then you try to do a union attack, inject custom queries, then try Boolean conditions, and try time delays. And a tool like SQL Map will just try all these attacks one by one and pump out the data for you. All right, I got one more Kahoot here. Let's get rid of this one and have this one. Aha, good. All right. All right, so what method gives you one yes or no question per query? That's it, a conditional error. All right, which one exposes data from local files? That's it, load file. All right, and which one gives you Windows command injection? That's XP command shell, good. And which one will create a local file? Okay, into out file, we used that quite a bit. All right, I know what that is. All right. Oh, cannot access the PDF? Oh, I thought I uploaded it. Let me take a look. It's here. Huh. Try refreshing the page. Also, by the way, you can go to this one, and that will give you a SlideShare version, and you can export this as a PDF. Yeah. Oh, and somebody's got some SQL labs. Oh, let's see. Oh, okay, good. Yeah, there's a lot of people who made SQL injection labs. Oh my. Wow, what a bunch of them. Cool. That's good. Let me save that. That's good. I'm going to throw it on the 129S page too. Well, I'd like to, but it looks like somehow I don't have the 129S in my... Oh, here it is. Good. All right. Good. Come on. Stop messing with me. There we go. All right. I'm going to throw it on Twitter too. I appreciate the tip. There's so many of these. I've got mine, and many people have written them. It's all very good. Yeah, well, absolutely. I appreciate the information. And there's ones inside Web Security Academy too, of course. There's a lot of them. Anyway, the lecture should be available. All right. Now let's take a look at the last bit here, which is, of course, defense. How do you block this stuff? All right, one thing you can do is just filter the apostrophes from all the input, and that'll stop the simplest attack, but it won't stop injection into numerical fields, where you can just take where there's a 1, you can have a 1 or 1 equals 1, add to that, and it doesn't take any apostrophe or anything. If you do allow apostrophes into data fields by doubling them, then you can have second-order SQL injection if you don't fix the underlying problems in your database, where you take data that originally came from some user, and you put it in a line of text and try to demarcate it with apostrophes as delimiters, which is just a fundamentally flawed practice. Now, some people say you should use stored procedures, And stored procedures serve the purpose of making it easier to reuse code. So you can create a procedure name, but it doesn't solve SQL injection. What it does is it just defines a shortcut name for a procedure, but that procedure might still use data from the user. So you could define a procedure called register user, which has parameters, username and password, but if these came from the user, then someone could still put in this password, and you would get this command to execute the stored procedure on this, semicolon, then execute some other command. So stored procedures do not address this problem. What addresses this problem is parameterized queries. What happens here is instead of having a line of text with apostrophes that have to find matching apostrophes and demarcate it, you have a command like this, where you, this is vulnerable code, where you have select ename cell from M, where ename equals one apostrophe, then the user applied name, then the other apostrophe. This is the vulnerable code we've been exploiting all along, where you have code that puts an apostrophe in, then puts in data from the user, and then puts another apostrophe, and then sends it to a parser that's going to try to match those apostrophes. What you should do is this instead. You say ename equals question mark, and then you prepare a database connection, and now it sets the string equal to the name. So what this does, there is no beginning apostrophe and ending apostrophe around it. There's just a placeholder saying, here's the code put by the developer, and here's the place where the data from the user goes, and that is a data object which cannot be misunderstood as a code object, so the data can contain any punctuation marks you want, apostrophes, parentheses, anything. It doesn't matter. It cannot be misunderstood as code. And then you can have apostrophes in somebody's name and just store them the way they are and use them the way they are without any problem. This is the right answer. Parameterized queries are essentially perfect, and as far as anybody knows, they completely end SQL injection. This is what people should be doing instead of creating a line of text containing punctuation marks that have to be parsed, which is what leads to all these code injections. So you have to use parameterized queries everywhere. It's best to just do it all the time. Otherwise, you're going to have to somehow try to make sure you know which data came from the user and which data didn't. And if you think about second-order SQL injection, even data you pull out of a database might have ultimately come from a user at some time. So it's better to just use it all the time. All right. Now, if you expect the user to be able to change something like the sort order, then some part of the query must be under the control of the user. But in that case, instead of putting in text that came from the user, you should just make the user choose from a list of valid values. And they are not allowed to inject arbitrary text. All right. Use low privileges, not database administrator. Put on vendor patchers, disable the dangerous functions like XP command shell, and so on. All the usual stuff. Then there's NoSQL. NoSQL, I'm not sure it's still that popular. Mongo turned out to be very popular. I don't hear that much about the other ones anymore. But the point of SQL is very limited. You have to have a schema that says something like, here's the date, which is like so many digits long, and here's the name is maybe 30 characters long, or the address or something. And if you ever want more than 30, tough. There was only room for 30. It's this rigid structure. And that isn't always good, especially for things like Google, where you're searching web pages, which don't have any structure at all. So NoSQL lets you have unstructured data, where the things can be of any size, and you can still do a certain degree of lookups and so on with these kind of technologies like XPATH or JavaScript. And so here's MongoDB. So here's how you log in. It's going to have a JavaScript function which looks for username equals this username that came from the user, and this password equals that password, and then it'll return that function. So here you are. You're going to check to see if the user ID passes this test, and then it's logged in or not logged in, that sort of thing. That's the kind of function. Now again, if these are untrusted inputs, you can still inject into here. You just have to put in something like Marcus apostrophe / / and that will do it. If the username equals Marcus and the rest of it is commented out, so you'll have the same thing. It will always log in as Marcus. Or the first, to log in with that username and any password. You can do it this way in JavaScript, and this would be interpreted as setting both the username and the password to accept any value, because it'll turn them both into compound conditions. And there's XPATH is another way to do it. This is XML data. XML data is like HTML, is a subset of XML, where you just have tags, like this is the beginning of the address book, and you have closing tags, the end of the address book. And the address book has addresses, and the addresses have first name and password and email and so on. And it's just a way of organizing data. And so this is a data store. And when you do a query in XPath, you would do it this way, with just punctuation marks and the names of the field. This would give you all the email addresses. And here you'd get all the information from someone named Dawes. This is how you put in a condition, like where username equals Dawes. And so you can do injection. Here's a query that retrieves the stored credit card number from a username and password. And you can put in this injection in instead of Dawes. And you'll get, or then instead of the password here, secret. And so you'll end up with this mess. And again, this is going to be a the correct injection with the right punctuation marks will again turn into something that dumps out all the credit card numbers. There's nothing in this structure that prevents SQL injection. It's no SQL injection in a different language. However, so you can find these things by just injecting things that will cause syntax errors and things that will change behavior without breaking syntax. If you want to prevent it, you got to filter with a whitelist is better than a blacklist, and you have to remove all these punctuation marks. LDAP is used to store information in Microsoft Active Directory and a lot of other systems, and this turns out to be far less vulnerable by design because the queries are designed in this way. You have conditions, and the connectors like and or always go at the start. So you have some kind of search term at various levels. If you put a pipe here, then any one of these will be true. If you put an and here, they have to all be true. But you can't put the and or the or anywhere but at the beginning, and that means injection just won't work, because you can't form or 1 equals 1. You can't put in the or. That was put in by the developer, and you can't insert it over here like where the username and password go. So just by the structure of the queries, it turns out to be very difficult to do an injection that does much of anything. So that's kind of cute. All right. This was a big deal about 8 years ago at DEF CON because the world believed that Oracle databases were not vulnerable to SQL injection. That was a common belief, and all kinds of government and insurance and important banks and everything were using Oracle and feeling like they were safe. And then they had a DEF CON or Black Hat talk where they showed how to inject into Oracle databases because they're just as vulnerable, and people freaked out and tried to stop that information from getting out. And there was a wide belief at the time that Oracle was not like other SQLs, but it is. And so are NoSQLs. None of them are intrinsically protected from these attacks. It's just that you need a different syntax for the attack. Has LDAP always had this? Yes, as far as I know, LDAP has always had this. It's just just the way it's designed, it makes it difficult to inject anything. You can, in principle, you can do injection, but in practice, since you can't inject and or, you can't really accomplish much of anything with the injection. All right. All right, so what's the best defense? Yep, that's it. Parameterized queries put the parameters in data objects that can't be misunderstood as code objects. Yeah. Well, you know, I don't think LDAP was designed with security in mind. I think it's just a coincidence. But anyway. All right, what defense might open second-order SQL injection vulns? That's it. You can double apostrophes when you store them, and that's a way to store an apostrophe that can be retrieved. But if you then put it in a non-parameterized query, it can lead to a second-order SQL injection. Which of these is least susceptible to injection? That's LDAP. All right, and which system has queries that look like that? That's XPATH. Okay. All right, and what system uses conditions like that? Okay, that's LDAP with the conditional right at the start where you can't reach it from the parameter, thus sort of accidentally creating a lot of security. All right. All right.